Chapter 15, question 13. The researchers cited in the previous problem also examined the weight-salary relationship for men and found a positive relationship, suggesting we have very different standards for men than for women. Judging Cable 2010. The following are data similar to those obtained for a sample of male professionals. Again, weight relative to height is coded in 5 categories from 1 equals thinnest to 5 equals heaviest. Income is recorded as thousands earned annually. Calculate the Pearson correlation for these data. That's A. And B, is the correlation statistically significant? Use a two-tailed test with an alpha of 0.05. So what we need to do, we're going to do the full 4-step hypothesis testing procedure here. So step 1 is to state our hypotheses. We need our null and we need our alternate. Now remember that the hypotheses are always stated in terms of rho, so the population values, and we see that, trying to decide whether we have a two-tail or one-tail test. In part B, we need a two-tailed test for our decision, so we're going to use a two-tailed test here. So the null is that rho is equal to 0, and the alternate is rho is not equal to 0. For step 2, what we need to do is we need to find our degrees of freedom, which is n minus 2. And we've got 1, 2, 3, 4, 5, 6, 7, 8 data points. So we're going to do 8 minus 2. So our degrees of freedom is 6. Our alpha is 0.05 and it's two-tailed. If we go to the table for the correlation, the critical values for the Pearson correlation, which in this textbook is table B6. Okay, so level of significance, we have a two-tailed test, so we're going to look here to determine what column. So alpha is 0.05, two-tailed test, so we're going to use this column. And we're going to read across degrees of freedom 6, and our critical value is 0.707. And because it's two-tailed, it's technically plus or minus 0.707. Step 3 is where we actually calculate our Pearson correlation. Now, looking at this data, looking especially at the y values, if we use the computational formula, we're going to get some really large numbers because 151 squared is 22,801. And my concern there is that that's a lot of numbers to press into a calculator, and it makes more numbers makes it even more likely that we're going to have some sort of calculator problem and we're going to make a mistake. So I'm going to use the definitional formulas here and hope for the best in terms of those means being nice, round, even numbers rather than having some crazy decimals. So the first is we need to find the mean for x. So the mean for x, we add up all of these numbers, so 4 plus 5 plus 3 plus 2 plus 1 plus 3 plus 1 plus 5, and we divide by 8. And yes, you really should show all of your steps and all of your work, because if you make a mistake, it is important to have shown your work so that your professor can see whether or not, what type of an error was it? Was it a conceptual error, using the wrong formula error, or was it because you pressed a button wrong in your calculator? And that may make a difference in terms of the part marks that are given. And it also demonstrates to your professor that you're doing your own work and not just copying from someone else. So this is 24 divided by 8, which is 3. I'm going to go ahead and calculate the sum of squares for x fully, and then I'll do the mean of y and the sum of squares for y. So to find the sum of squares of x, using the definitional formula, we're going to take each x score, subtract that mean that we just calculated, square it, and then add it up. So we need a column x minus the mean of x. So 4 subtract 3 and so on. So 4 subtract 3 is 1, 5 subtract 3 is 2. We need to square those. So now we take 1 squared. Remember, 0 squared is 0. Negative 1 squared is 1. So a negative number squared is always positive. Now we're going to add all of these values up. Sorry about that. And if we add those all up, we get 18. And we're going to now do the whole same process for the y scores. So we need to find the mean of y. So 151 plus 88 plus 52, 73, 49, 92, 56, 143, divided by 8. And that is 704 divided by 8, which is 88. So we're going to take each of these scores and subtract 88. So y subtract its mean. So that is 63, 0, negative 36, negative 15, negative 39, 4, negative 32, 55. We're going to take each of these scores and square them. So 63 squared. We are getting into some large numbers, but not as large as if we were using the computational formula. Now I'm going to have to go to a separate page, but I'm going to add up all of these values. So the sum of squares for y if we add all of those numbers up, get 11,076. So now we have the sum of squares of x, we have the sum of squares of y. We need to calculate the sum of products. So coming back here, what we need to do is we need to multiply this column by this column. So x subtract its mean times y subtract its mean. So we're going to take the difference scores and multiply them together. So 1 times 63 is 63, 2 times 0 is 0, 0 times negative 36 is 0, negative 1 times negative 15 is 15, negative 2 times negative 39 is 78, 0 times 16 is 0, negative 2 times negative 32 is 64, and then 2 times 55 is 110. So for the sum of products, we're just going to add up all of those values. So 63 plus 0 plus 0 plus 15 plus 78 plus 0 plus 64 plus 110 is equal to 330. So now to calculate the R, what we need to do is we take the sum of products divided by the square root of the sum of squares of x times the sum of squares of y. So 330 divided by the square root, the sum of squares of x was 18, times the sum of squares of y, which was 11,076. So 18 times 11,076 is, that's 330 divided by the square root of 199,368. So that's 330 divided by 446 point, let's keep two decimals, 51. And so then that is equal to 0.7. Let's continue. Well, let's do 3 decimals. 739. And there ends part A, because that just asked for calculate the Pearson correlation. Part B asks if it's statistically significant. So I'll leave that for the next video.